Hello, welcome to the video on equations of lines. Again, this should be mostly review from Algebra 1 from last year, so hopefully it'll go very well. Through an infinite amount of points. So we have three different forms of lines that we use. The first one is the most popular one. It's slope-intercept form, y equals mx plus b. The second one, in my opinion, should be the more popular of the three, the most popular of the three, and this is point-slope form, where you have y minus y1 equals m parentheses x minus x1. So, as you know, a line goes through an infinite amount of points. You choose one of the infinite amount, and the point that the line goes through is x1 comma y1. So any point that the line goes through you could use to write this form. And then the last one is ax plus by equals c. That's standard form. A, b, and c are all integers, so no fractions, no decimals. All right, so notice a couple of things here. When you have slope-intercept form, m is in the equation. Point-slope form, m is in the equation. Let me highlight that a little bit better. So when you look at the equation in either of these two forms, you can pull the slope out. You know exactly what the slope is. Standard form, that's not the case. You can't look at the equation in standard form and say, oh, there's the slope. It's not. Notice it is not attached to the x. That is some integer value that is not the slope. That is a common mistake that students make, is they think the number in front of x is always going to be the slope. That's not the case. It is when it's in slope-intercept form. Yes, the number in front of x would be the slope. In point-slope form, slope is in front of the parentheses. That's always going to be the case. Standard form does not have that. All right, let's go ahead and do our first example here. It says to write an equation in slope-intercept form of a line with a slope of 6 and a y-intercept of -3. Then we will graph the line. So the first thing I notice is they want me to write it in slope-intercept form. Remember that slope-intercept form is y equals mx plus b. It's the most popular of the three forms, I would say, the most recognized. So the slope here, 6, that's m. The y-intercept of -3 here, that's b. So b is -3, m is 6. If they just give you those two values, you go ahead and plug it into the equation, y equals 6x minus 3. Let's graph it. I always tell my students the b is where you begin on the y-axis, so we're going to go down to -3. Now the slope, if it is 6, that is 6 over 1. So our rise, if we go up 6, we'll go right 1 because it's positive. If we go down 6, we're going to go left 1 because then that's a negative over a negative. Don't forget, positive is up is a positive direction, right is a positive direction, down is negative, left is negative. So a negative over negative will be a positive. So going down 6, I'm not wanting to do that. Because I don't have enough space. So I'm going to go up 1, 2, 3, 4, 5, 6. Now, again, I always think to myself, my line has a positive slope. It should be rising left to right. So if I was to connect this blue dot to the yellow dot, it is rising. 1, 2, 3, 4, 5, and I'm off the grid slightly, 6. Let's label our points. 3 points should always be labeled, 0, -3, 1, +3, 2, +9. Okay, and we're done with that one. Next, we are going to write an equation in point-slope form, so a different form this time, of a line with a slope of 4 that contains the point -10, 8. So notice that I labeled that x1, y1 because point-slope form is y minus y1 equals m parentheses x minus x sub 1. I plug in 4 for the slope, and then -10 is going to be x1, 8 is going to be y1. So y minus 8 equals, the slope is 4, x minus -10. I don't like the way that looks. I'm going to rewrite it. I could have right away written x plus 10 if I'm comfortable doing that. And that is my equation in point-slope form. There's no reason to distribute. There's no reason to try to write it in slope-intercept. Leave it like this. I'm going to go ahead and graph this line. I noticed that -10, 8, this is always going to be your starting point. Instead of having a y-intercept, now we just have a different starting point. My graph is too small. My units only go up 1, 2, 3, 4, 5, 6, 7, 8 in each direction. So I'm not going to be able to go to negative 10. So what I'm going to do is make a note on my graph, and you could do this in your science classes, you could do it in your math classes. I'm going to change the units that they're going by 2s. So now when I plot negative 10, 8, I'm going to go to the left, 2, 4, 6, 8, 10. So 5 units accounts for the negative 10, right? If I'm going by 2s. Now I'm going to go up 2, 4, 6, 8. This point is negative 10, 8 because I did change my units. So that should be no problem. What's going to maybe become a little bit of an issue is my slope is positive 4 over 1. So if I go up 2, 4, I only go half a box over for the 1, because if each unit is 2, then I have to go to the right only 1 unit. So now I'm at negative 9, positive 12. Let's say I decided to go down 2, 4 over 1. I am now at negative 11, positive 6. And I draw my line, and I make sure that I put arrows at the ends to show that this is in fact a line. Okay, so point slope form, always plot the point, that's your starting point, and then use the slope to get other points along the line. If you have slope intercept form, you always start at the y-intercept and then plot points based on your slope, more points. All right, so now we're going to get a little bit more complicated with example number 3. We are going to write an equation of a line through each pair of points, and then we're going to graph them. So here, these directions could be a little tricky. It says point A is goes through 4, 9, and B, negative 2, 0, and through negative 3, negative 7, parallel to line AB. So basically, we are writing this, the way that this is written can be confusing. We are basically writing 2 different lines. We're writing this one that's going through point A and B, and then the second line we're going to write goes through a different point, but it is parallel to line AB. So I've written here a very, very important thing to remember when writing equations of lines. In order to write the equation of any line, you need to know 2 things about the line. You need to know, number 1, the slope, and you need to know a point that the line goes through. If you have those 2 things, you can write the equation of any line. So go ahead and pause the video, write down what I did here in yellow, because it is the single most important thing that you need to remember. To write the equation of any line, 2 things you need. Its slope and any point. A lot of times kids think it has to be the y-intercept. That is a very specific point. It doesn't have to be the y-intercept. It could be any point. Okay, so hopefully you paused it and wrote it down. Let's go ahead and do this problem now. Let's first find the equation of the first line. All right, so the first line, we're going to find the slope of it. So the slope of AB is going to equal y2 minus y1. I could start with any y I want, like we learned about slope, and then 4 minus negative 2. This is going to give me 9 over 6. Of course, I'm going to reduce this. It's 3/2. So now I have 2 points that my line goes through. It goes through 4, 9, and 2, 0. So if I'm going to have a choice, I'm going to write this in point slope form. Y minus y1, where this is x1 and this is y1. Y minus 9 equals the slope that I just found, 3/2 x minus 4. But now, who's to say that A is x1, y1? Who made that decision? What if instead I thought, well, no, I want this to be x1, y1? There's absolutely nothing wrong with that. If I use the second point as x1, y1, I'm going to get y minus 0 equals 3/2, the slope that I just found, x minus negative 2. I'm going to clean this up. This minus 0 is unnecessary. It's 3/2 parentheses x plus 2. Either of these answers would be acceptable. I wouldn't recommend writing both of them, because if you mess one of them up, let's say on a quiz or a test, then your teacher is going to be forced to take off points. But if you write one of them, you have maybe slightly better odds of getting that right. Okay, let's go ahead and graph this line. So I will go to the point 4, no, I'll go to negative 2, 0, because 4, 9 is off my graph. And now the slope is 1, 2, 3, up 3, right 2. This brings me to 0, 3. That is the y-intercept. Up 1, 2, 3, over 1, 2. This brings me to 2, 6. Connect it, draw your arrows at the ends. If I went up one more time, 3 and 2, that would bring me to 4, 9, because it'd be to the right 2 and up 3. Okay, now let's write the equation of the second line. All right, so the second line, it says, is parallel to our line. So you need two things. The slope of the parallel line then, two lines that are parallel have the exact same slope. So the slope of the second line is 3/2. So I'm going to put this in pink to kind of color code it. All right, so now here is my x1, y1. I'm going to write the equation. Y minus -7 equals 3/2 x minus -3. Clean it up, we end up with y plus 7 equals 3/2 x plus 3. All right, to graph it, I'm going to go to -3, -7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And now that point, -3, -7, I label it on my actual graph. Go up 3, right 2. I'm now at -1, -4. Up 1, 2, 3, over 2. I'm at 1, 1. Connect the line. Now, I don't have notability on here. It's a little bit not as straight, not as nice, but these lines should be parallel. Like, I think I just kind of went over too much over here. And that's 1, -1. Sorry about that. Okay? That's how you do that problem. All right, if you're writing the equation of horizontal and vertical lines have a slope of 0. I talked about this when we did slopes, where you could use part of the line to write the z for 0. And so for example, y equals 0, x plus b is only going to be y equals b. So for example, y equals 3. If I take a y and flip it upside down, it kind of looks like the h in horizontal, if you kind of use your imagination. So y equals, if you flip this and kind of rotate it, it kind of looks like an h. Vertical lines have undefined slope. So therefore, you can't write it in slope-intercept form, because you can't put undefined in front of it. So a vertical line is always going to be x equals, the way I always tell my students to remember, this is like a V upside down and right side up, and x equals, and it's always going to be a number. Y is not, it doesn't come into play at all when you write the equation of a vertical line. All right, so the first one, writing equation of a horizontal line that passes through the point -7, -8. Here are my 2 points, -7, +8. If I was to graph this, I'd go left 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5, 6, 7, 8. Put a dot there. It's a horizontal line. So horizontal line, take that h, flip it upside down, looks kind of like a y, and you go to the ordered pair to find what y equals. Doesn't matter what x is equal to, y is equal to +8. All right, try example number 5 on your own. Write an equation of a vertical line that passes through -4, +3. All right, hopefully you get x equals, because a vertical line is always x equals, and it's -4. Okay, now for example 7 through 9, we have a few different things we're going to do here. We're going to write the equation of a line that's perpendicular to the line that's given, y equals 3/5 x plus 4, but it's going to go through the point 0, 8. So here's the thing. The only reason they ever give you this line is for you to grab its slope. This line here has a slope of 3/5, which means our line that's perpendicular is going to be the opposite reciprocal. So our line has a slope of -5/3. You flip it and you take the opposite sign. Now our line goes through the point 0, 8. So we have the two things that we need to write the equation of a line in any form. It didn't specify which form, so I could write it in any. So if I decided to write this in point slope form, it would be y minus 8 equals the slope -5/3 x minus 0. all of that minus 0 part is not necessary. So I could just write this as y minus 8 equals negative 5/3 x. But I want you to notice one thing. This ordered pair here has a 0 for x. Whenever you have an ordered pair and you have 0 for x, what that means is this is the y-intercept. If x is 0, the number in the y value, that's the y-intercept. If you have an ordered pair, a number comma 0, that's the x-intercept. So you could have also written this in slope-intercept form. It would have been y equals negative 5/3 x plus 8. Okay, so either one of those is fine as your answer, and even this one. Okay, for example 8, we are now going to be writing an equation of a line that's parallel to y equals negative 3x minus 7 through the point negative 4 positive 3. Remember, we need two things to write the equation of any line. We need its slope and we need a point. So here, if our line is parallel to this line, then the slope of our line is also negative 3 because parallel lines have the same slope. The point that our line goes through is negative 4 positive 3. I am going to write down a mistake that many kids make. They say, okay, the equation of this line then is y equals mx plus, and then they pull this 3 and think that that's the b value. It is absolutely not the y-intercept. How do I know that? Because the x value is not 0. All right, so that is incorrect, but it's a very common mistake that students make, so try not to do that. Try to get out of that habit. You can only use the y value as the y-intercept if the x value is 0 of that point. All right, I'm going to pause the video. I'm going to write down the correct answer. You guys pause it as well. Try to write the equation in this line. Let's see if you get it right. Okay, so here's the answer. Y minus 3 equals negative 3 parentheses x plus 4. If you did not get that right, please make sure you ask your teacher what you did incorrectly. Also, you don't have to distribute this. A lot of kids also want to distribute. Solve for y, solve for y. You absolutely don't have to do that, okay? All right, this last one. Write the equation of a line perpendicular to this line, 2x minus 3y equals 12, through the point negative 1, negative 6. Okay, so we have one thing that we need. We need our point. So the point that our line goes through is this one. But now we need the slope. So what that means is we have to find the slope of this line and then take the opposite reciprocal, and that is going to be, well, that's supposed to be a star. That is going to be the slope of our line. So the problem here is we haven't had this yet. This hasn't popped up. This is a standard form. This line is in standard form. So it's ax plus by equals c. I said in the beginning of this video, I said, if it's in standard form, you can't look at this equation and say, oh, okay, I know exactly what the slope is. You can't. So what you have to do is take this equation, and we're going to have to solve it for y so that it's in slope-intercept form. It's going to be y equals mx plus b. We're going to take that number in front of the x, and that's the slope of this line. So the first thing I'm going to do is subtract 2x. When I subtract 2x, I'm left with negative 3y equals negative 2x plus 12. I like to put the term with x first because I want it in slope-intercept form. So then, when I divide by negative 3, it's imperative that you divide every single term by negative 3. You can't just divide the last term by negative 3 because then you're not making this equation equal. So now we get y equals, we're going to clean this up. Negative over a negative is positive 2/3 x, and then minus 4 or plus negative 4 because we have a positive and a negative. But really, the y-intercept, I don't really care about it. It's not important to my problem. The only thing I want here is this line's slope. Why do I want its slope? Because my line is perpendicular to it. So the slope of my line is the opposite, so negative, and then the reciprocal 3/2. All right, so we have our slope, we have our point. I'm going to write the equation of the line. Y minus y1 is going to end up y plus 6 equals all that work I went through to find this slope. It's positive 3/2, and then x minus x1 is going to be x plus 1. So the only form that if you are given a line, the only form that doesn't right off the bat, you can't look at it and tell what the slope is in standard form. So when you get that, just know that you're going to have a little bit of work to find that slope. Right. Finally, we're just going to finish off with a little bit of quadratic review. If you've been putting off learning how to solve or factor quadratics, not a good idea. Make sure you learn how to do it because quadratics are not going away this year. So go ahead and try these on your own. I will display the answers, and if you have questions, it's something we'll go over in class tomorrow. So go ahead, pause the video, and then when you're ready to check your answers, press play. Here are the answers to these 4 review problems. The first 2, you're supposed to only factor. So you are not solving. It's not an equation. You're not solving. We don't know what this equals. It could equal 1 billion for all we know. If you're solving it, you're assuming that those equations are equal to 0, and we just have no proof of that. So the first one is a difference of 2 perfect squares, a squared minus b squared. You have to memorize that formula. It's a plus b, a minus b. All right, the second one, we're looking for 2 numbers that multiply to be negative 28 at the same time add up to 3. This is an easier one because the number in front of x squared, the a value is 1. And then solve by factoring, you always want to get those equal to 0 unless you're square rooting. But here you set them equal to 0 and then factor. So for the first one, you should have gotten 6 or negative 4. The second one is 0 or 8. If you did not get that as your answer, please, please, please seek help. You need to know how to factor and deal with quadratics in this class. It's one of the requirements for all students. All right, that's it for 2.4. That was a lot of information in one video. I would say that's multiple weeks in Algebra 1 that we just covered. And then we added in the geometry part of parallel and perpendicular lines. So that was a lot. Make sure if you have any questions that you ask your teacher. Sorry about this typo I noticed right here. Next time in class, you're going to practice writing equations of lines, and your teacher's going to do quick notes with you on graphing lines in class. Thank you so much for watching. Have a great day. Bye.